This class question is actually from chapter 3, review problem, and we're trying to figure out what the sample correlation between x and y is, and we're trying to do it by hand. So first step is we want to find the sample correlation, but in order to do that we need to find the sample size and x bar, y bar, and so on. So sample size equals, we can do a count function, or we can just look and see that it's 19 and right there. Now it's important to realize that we just want to count each one of these students one time instead of each x and y as one and get twice as many. That doesn't make sense because each xy is considered like one data point. So the total number of data points is 19. Sample mean, we can just use the average function. 88% looks good to me. Average again for the sample mean of y. .053 sounds good. Alright, let's start filling in the chart area. So xi, this is xi, represents x1 minus x bar, 88%. Put dollar signs around the x bar. That way we can copy and paste and it'll keep that cell where it's at. Now we want to square it. Y sub I minus y bar. Here's our y sub I, or y1 minus our y bar. Dollar signs. Again, we want to square it here. And x minus x bar times y minus y bar. So that's right here. Notice it is not we're not multiplying the squared ones together. So mistake some of you guys made. And now what I can do is I can just copy this whole row and then select the beginning of all the rows I want to paste this to and just paste right on top. There we go. So that's finished. Now let's figure out the sample covariance. Here's our equation for sample covariance. It is the sums of xi minus x bar multiplied by y sub I minus y bar, and that's right here. So we want to sum this column. Now that represents our numerator in the formula right here. And now we want to divide by n minus 1. So there's our sample covariance. I like it in decimal form. Variance of x. So here's our sample variance formula. And we're taking the sum of xi minus x bar squared. So find your xi minus x bars. That's right here. Now we want to sum them. And divide that by quantity n minus 1. Make sure that denominator has the parentheses around it. And notice this first part, this numerator right here, this guy, that represents the SSD of x. Standard deviation is simply the variance of x square rooted, or you can take it to the 1/2 power. Variance of y. So we're going to take the sum of y minus the y bars. Divide that by the same thing, n minus 1. Our standard deviation of y, we can use the square root function, or we can take it to the 1/2 power. Same thing. And our sample correlation. So look up the formula here. Here's our sample correlation, and the numerator is the sample covariance, and then you divide that by the quantity of the standard deviation of x multiplied by the standard deviation of y. So sample covariance divided by the quantity, so open parentheses, standard deviation of x multiplied by standard deviation of y. Looks good to me. You're getting ready to go out for the night, but you can't decide what to wear. You've narrowed it down between 3 pairs of shoes, 2 pairs of jeans, 4 pairs of 4 shirts. How many outfits do you currently have to pick from? Well, let's put this in here. You have 3 shoes to choose from, 2 pairs of jeans to choose from, and 4 shirts remaining. And this is like a sequencing problem, like a stepping problem. So each section, you just multiply each section together to get the total number of possibilities. So total outfits is just going to equal 3 times 2 times 4. Now let's make this look a little nicer. Put this over here too, and maybe we'll bold this. And set our answer equal to 24 outfits. Question 5. You took a trip down the Hoshir Casino. In one game, you are asked to draw a hand of 5 cards from a full deck. How many possible different hands can you have? So, first step is to realize that this is a picking problem. Second step, when you realize it's a picking problem, you ask, does order matter? And if you have a deck of 5 cards, the order that you get those 5 cards in your hand doesn't matter. You can rearrange those cards any way you want, and you still have the same 5 cards. So order does not matter. So picking problem, order doesn't matter. And since order doesn't want to matter, you want to use a combination. So number of cards in the deck, and that's represented by big N is the notation for that. Number of cards in your hand, that's how many you are picking, little n. And let's capitalize this. Number of cards in the deck is 52. Number of cards in your hand is 5. And so your total number of possible hands, or your total number of combinations, equals combination 52, and you're picking 5. So let's bring these over here, and we can add commas and get rid of the decimal points. Looks pretty to me. And set that equal to our answer. Looks good. Next problem. Xavier's baseball coach was fired and the school puts you in charge. You have 15 players on your team. You have to create a 9-player lineup. How many different possible lineups exist? So again, this is a picking problem. And the first thing you ask yourself is, does order matter? Yes, in a batting order, if you have Jose batting first or if you have Jose batting last, those are 2 different batting lineups. So order does matter. Next point is, if order matters, then you want to use a permutation. So players on team, that's the number of players that we're picking from, represented by big N. Then we have players in lineup, and that will be little n. We have 15 players on the team. We're picking from 9, and total possible line ups. We just want to use the permute function. 15, pick 9. Same thing. Let's move these over here. Add the commas and remove the decimal points. Set our answer equal to that value. Good to go. Alright. Question 7. Use the given probabilities to calculate the probability of B. Here's our given probabilities, and here are given equations. Now, I just put these given equations here. These are your two go-to equations whenever you're doing probability and you're looking at unions or intersections or given conditional probability. And so we look at these two equations and we can use the addition law. So I'm going to copy that additional law because I want to put that in my workspace. Paste special, and I'm just going to paste the values because I don't want the formatting. I like the workspace formatting for the workspace. And you can see I want to insert a comment, and I can do that by putting in a little little comment indent thing, which is that button's right by your enter button, and it lets Excel know without putting in the formatting up here that you are doing a text entry. So our probability of A union B is known. It's 0.9. That equals the probability of A, which we know is 0.5, and plus the probability of B. That's what we're trying to find, minus the probability of A intersection B, which we know to be 0.2. So probability of B. Well, let's actually first reorder this equation so we get probability of B by itself. So another comment thing, 0.9, and let's subtract negative 0.5. Let's subtract 0.5 from each side, and then add 0.2 to each side. And now we're left with probability of B on the right. So now we can determine what probability B is. We can just type these numbers in, or I'm going to reference them up here. So 0.9 minus our 0.5 plus our 0.2, 0.6. Set our answer equal to that. Problem number 8. Use the given probabilities to calculate the probability of A given B. Looks like we're definitely going to have to use our multiplication law because it has the given probability in it. So I'm going to copy that and paste values down here. And I use the keyboard shortcut, which is Control Alternate V, but you can also copy, go to where you want to paste, right click, paste special, and then values. That'll do the same thing. So let's see what we know here. We know the probability of A union B, that's 0.2. And that's going to equal what we want, the probability of A intersect B multiplied by the probability of B, which is 0.4. So let's divide 0.4 by each side, and we have 0.2 divided by 0.4 equals the probability that we want. And I'm just going to steal this right here and put that guy right there. So probability of A given B is going to equal our 0.2 divided by 0.4, 0.5. Set that equal. And this is really, I'll make this a little prettier. There we go. Alright, so last two problems. Question number 9. You've already read over the problem, so we're going to jump right into the solution. After the review, the consulting firm believes that the financial adaptations will be considered lawful. What is the probability that your company implements the adaptations this year? So this is Bayes' theorem. You get some given probabilities, and all of a sudden something becomes known. And then since something becomes known, although this whole time we're interested in we were really only interested in the probability that the company implements the adaptations this year. Now, since it's known that the consulting firms believe that the adaptation will be considered lawful, we don't just want to know if the probability of the new implementations will be adapted this year. We want to know the probability that the adaptations will be implemented into the company this year, given that the consulting firm considers it lawful, because we know that to be true. So this is exactly what we want right here. I've already, built some framework for this problem to speed up the video, but we want this probability of A given X, and just from the multiplication rule, we can get to this point right here where we say probability of A given X equals probability of A intersect X divided by the probability of X. And it's important to note for the multiplication rules that if you're looking for the probability of A intersection B, that's equal to the probability of A given B times the probability of whatever was given. In this case is B, but it can also be the other way around. You can also say that probability of A intersection B is the probability of B given A multiplied by the probability of whatever is given. In this case, that's probability of A. So from there, you can apply the logic to get this equation in terms of a conditional probability equation for conditional probability, and you can simply put it together and get that step. So let's break this equation into two parts, the numerator and denominator, and let's solve for both of them, and then we can get this probability. So step one, solving for the numerator, the probability of A intercept X. And once again, we're going to go back to the multiplication rule. Probability of A given X equals probability of probability of A intersect X equals the probability of X given A multiplied by the probability of A. And so when I started out, I knew that I wanted this component. I knew I needed to find that, and I asked myself, and I knew the way I was going to do that is I'd have one component that'd be conditional probability, and I'd multiply that by whatever was given, probability of whatever is given. So I asked myself, oh, I want the probability of A and X, so I need conditional probability using X and A, and then I look at what I know. Because I could use, I see that I know the probability of X given A, so that's what I use here. But another equation that would also be correct would be the probability of A intersect X equals the probability of X, the probability of A given X multiplied by the probability of X. However, we don't know what the probability of A given X is, so stick to what we know. Anyways, so we can just put that right in, and the probability of X given A right there multiply by the probability of A, 0.34. Now probability of X, that's a little bit trickier, and this is Bayes' theorem, and pretty much what Bayes' theorem says is we don't know what the probability of X is, but we do know what the probability of A and B and C are, and we can solve for what the probability of X intercept A, X intercept B, and X intercept C. And so since A, B, and C are all mutually exclusive parts, we can just sum them together and get the probability of X. And I have a PDF document that's posted, and it can help you. I solved this by hand with like a written explanation, and so that can help you figure this out. What I want to focus on is this component of the problem, finding p sub x, and conceptually you can think of it as you have this probability space that's right here, and we're interested in x. However, we don't know what x is, but we do know A, B, and C. A is the probability that it's implemented immediately, or B is the probability that it's implemented at the next fiscal year, and C is the probability that the changes are implemented by your company, are not implemented at all by your company. And so this makes up the probability space. And when I say they're mutually exclusive, that means something can only be A, or it can only be B, and it can only be C. You can't have, there's no overlap in between any of these events, and it has to be one of these events. So that's mutually exclusive, and you can imagine dividing the probability space up into these parts. And so that's what I kind of did down here. And if we knew what X and A was, which is this guy right here, and if we knew what X and B was, and if we knew what X and C was, if we then added all that together and put it back together, then we'd have dx. So that's the idea of Bayes' theorem. So now we're at this point. We understand why the probability of X equals probability of X intersect A plus probability of X intersect B plus probability of X intersect C. And now the question is, well, how to figure out what the probability of X intersect A is, and X intersect B, etc. And we just go back to, once again, the multiplication rule, where probability of, A intersect B is just going to be the conditional probability of those two things multiplied by whichever one is the given. So we know in the problem, let's go back to Excel. We know in the problem, trying to find probability of X intersect A, we know X given A, and we know the probability of A. So here we can solve for that intersect. And the same is true for the rest of those cells, the rest of those intersects, and the probability of X will be the sum of all those guys together. So that is the probability of X, or the probability that the consulting firm believes that the financial adaptations will be considered lawful. That was the initial probability that would be the case, and now we know that's given, that is true. So now we can solve for probability of A given X, which is simply right back up here to this formula, probability of A intersect X divided by the probability of X. And there we have it. And I already put in the answer cell. So last problem, I've already completed it for you. Find the probability of A complement given X, or the complement of A given X. And what's important to remember here is the complement of anything is just 1, the total probability, minus the original, so probability of A. And as long as the same thing is given in each case, then that is true. Here, the probability of the complement of A given X and the probability of A given X, the same thing is given. So you can use that 1 minus the probability of A formula. And that's exactly what I did. Here's the probability of A given X. We just solved for that in this problem. And you just take 1 minus probability of A given X. There's your answer. So thank you. If you have any questions, email me, go to my office hours, just let me know. Thanks.